make your comparison between the two graphs where y equals the absolute value of x, which is going to be that v that we talk about from parent graphs. Okay, so I just draw that v right there, and I know that's y equals the absolute value of x. Now the next thing it's trying to see is in 11 is there's 11, 12, and 13 is you're trying to understand how standard form, how the parent graph of this works. And so when it changes the number that's sitting out there by itself, all this does in number 11, y equals the absolute value of x plus 4, is take that same v right there and move it up 4 units. So you know you got in mind here, you're going to draw this v. You got this thing that you're going to draw. This function that you're going to draw is called the absolute value of x. And the way this function is getting changed is it's getting moved up 4 units. So you just go up 4 units and draw that same v. So there's y equals the absolute value of x. Now in 12, it takes this right here and changes it a. So 12 is y equals 3 times the absolute value of x. And the way this works is when you have an a out front, that multiplies your up value. So normally in an absolute value, you go up 1 and right 1, up 1 and right 1, up 1 and right 1. And that gives you that v that we're looking for. Well, this 3 right here tells you to multiply your up values by 3. So instead of going up 1 over 1, now you're going to go up 3 and over 1, up 3 and over 1, up 3 units and over 1. And then do the same thing on the left. You go up 3 and left 1, up 3 and left 1, up 3 and left 1. And the reason I don't continue on in a straight line is because these aren't lines. This is y equals the absolute value, y equals 3 times the absolute value of x. See, if I were graphing a linear equation, you keep going, keep going, keep going. Here, you always go back to your vertex. So, your vertex, up 3 over 1, up 3 over 1, that gives you one side of your absolute value. Up 3 left 1, up 3 left 1, up 3 left, that gives you the other side. And it's because this number is 3. And then your vertex is always HK. And 13, problem number 13 gets us to what's important in terms of understanding how these things work with moving the H and K. This says y equals absolute value of x plus 2. Plus 2 is a positive 2, so you think it'd move which way? You think it'd move right 2. You got to see, you said up. Look, this number's outside of. This is outside. This is what moves it up or down. This one that's inside the absolute value moves it right and left. So K moves the vertex up and down. H moves the vertex right and left. And that vertex is at HK. So what that means is y equals the absolute value of x plus 2 is I'm going to say I'm going to draw that, have that same absolute value of x, v in my mind, but realize it's going to get moved left 2 units because that's a plus 2. It's opposite. It's always opposite the number inside the absolute value sign. This should be number 13. It says, explain how y equals absolute value of x plus 2 differs. And it differs because it's been moved 2 units to the left. Problem 14, all right, you got it. You did it right. You just keep working. I'm just trying to fix this out here. It says, make a table of output functions for y equals 2x plus 4. So if the x values are 1, I just create a table right here. 2 times 1 plus 4. You just repeatedly go through and plug in these numbers right here. So 2 times 1 is 2, plus 4 is 6. 2 times 2 is 4, plus 4 is 8. 2 times 3 is 6, plus 4 is 10, 12, and 14. Sometimes they'll ask you what these values are for the domain and range. And remember the x values of the domain and the y values. The y values are known as the range. In number 15, I have to write a function rule that matches the input-output table, so when you get finished, you're going to have an answer that says f of x or y equals, remember if it's f of x, it's just called function notation. If it's y equals, it's just a linear equation, but it's the same thing, just moving the numbers around. So the first thing you have to do is you have to find a way to write an equation in y equals mx plus b form. So one of the things that I want to find, I want to plug some numbers in here and see if I can't find out what some of these values are. In this problem, I don't have b. There's no way to find b right there. I can look and kind of anticipate what the change in y is going to be because it looks like the y's are going up by 4 every time. So I know that's certainly one thing I could try right there. The equation that I can start out with, it looks like my slope 11 minus 7, 15 minus 11, 19. I'm taking the ranges and doing the change in y over the change in x. So that would be 4. So y equals 4x plus b. So there's the first thing I do is come up with the equation, and then I can take any points here and plug it in. So I pick a point in 1, 7, 2, 11, 3, 15, and I take those points and I plug them in for x, plug them in for y. And so I might get something like 11 equals 4 times 2 plus b. And so now I solve the resulting equation. What's 4 times 2? So 11 equals 8 plus b. So b is 3. So now what I can do is I take the information that I gathered from before. When I found my slope was 4, and my y-intercept is 3. So I come up here and say f of x equals 4x plus 3. If I want to check it, I can plug in several points from the equation. I just change it to y equals instead of f of x. Remember, f of x is called function notation, and so I just take some points and plug them in right there and see if they give me the correct answer, and they do. So this is my input-output table that I started with, and the first thing I did when I looked at my data is I knew I needed a slope, and so, or I needed the y-intercept 1. If it had been listed, I could have used the point 0, b to find my b minus my y-intercept.